I don't love this. This, I think, is a mistake.
Hello everyone and welcome to the second video online channel, and it's the day 2 of Go programming, and let's get started.
So in the previous video, we learned about packages, variables, and functions, flow control statements like for, if, else, switch, differ, more types, stop, slice, and maps. And in this video, I'm going to learn about methods and interfaces first. So let's go. So methods, Go does not have classes, so it has methods. So what is it? So what is happening? Func babe. Okay, so this is a function. It is a method robotics. So this is the method name, and this is the receiver. What you can see is we can do b.abs. Okay, cool. Next, methods are functions. Okay, next, it's just the same thing. Next, okay, you can also declare type like this, and you can declare. You can also extend the methods on the type as well. Pretty cool. It reminds me of Fed in Rust, which is pretty neat. Next, pointer receivers. So what is it? It is gonna multiply by 10. Awesome. Now if I just remove this asterisk, what will happen? It's just 5 because you are not changing to the exact thing, but you are just changing it to changing the value. So that's why. Cool. Next, pointers and functions. Now if I just do this, yeah, it's just the same things, man. It's just the same thing. Methods and pointer interaction. Comparing the previous two examples, you might notice the functions with pointer. I must take a pointer. Yeah, I've already noticed that. Next. Yeah. Next. Nothing new. Choosing a value on pointer receiver. Yeah, you need a pointer if you want to change the value of the object. Or what is it called? I guess it's an object here also. Otherwise, if you don't need to change the value, then you can just use normal their value. Interfaces and interface type is defined. Okay, I didn't know about interfaces. Import format math type ABS here absurd. Okay, interface. It has a method called ABS, I suppose. If you go to my float is a float. So let's look at this function. So this is okay. Cool, fine. Type vertex. I just prints absolute. This also is absolute. So just redefining it just makes it difficult. So you have to just using interfaces. Okay. I think I got it. So type type ABS ER interface. So it contains ABS float 64. So you can see here type my float has a method called ABS. I would return type float 64, and so does vertex. So using a variable called ABS ER, it can have value of both my float and vertex. So that's basically it. Interfaces are implemented implicitly. There is no explicit declaration of intent, no implements. This method means type T implements the interface side. So you don't explicitly mention it, but it is just happening underneath. I don't think that I love it because this is a strongly type language. Why so weak? Why? I mean, you are just going to create confusions in how these methods come and how you defined. Why does this work, right? I don't love this. This I think is a mistake. I'm just a no programmer. What can I say though? So let's just move to next interface values, value type. I mean, it's just what I've been thinking all along, right? Is there anything else? No. Interface values with nil underlying values. I mean, it's nil. What can I say? Nothing else. What's next? Nil interface values, it can have nil value because by default it's nil. Interface empty. I mean, it can do anything, right? Yeah, interface. Okay, this is pretty neat, I think. No, I don't think it's neat, but so Go can be a loosely typed language also. Weakly typed language also using interfaces. A pretty good option for sometimes or just new developers who prefer weakly typed languages. But sorry for offending all the weakly typed language users, but what can I say? It's just truth. Next, type assertions. It's also type assertions. Okay, type switches. Fine. Stringers. Stringer. What is stringer? I don't get it. Okay, it's a string F. I mean, so I have an exercise. Add a string method to I just like this. So 0, comma P1, comma P2, comma P3. and I can just remove this dot percent v dot percent v dot percent v. Done. There you go. It's worked. Next, errors. Error not equal to nil. Here we go. I'm late to the train, but here I am. Okay, next. Wait, let's just dive into this. Okay, let's just look at this. Okay, you are defining your custom error. It means, right? I mean, it's just an error handler then. So okay, let me try to understand it. Okay, so let me try to understand it. Error. So error. So it returns error if error is not equal to nil and print. Okay, let's just print it. It didn't work. Okay, it's just returning an error. If I just do this, accent if x equals 0, return it. And if I just 0, then it's gonna not do anything. And if I just some random number, it's gonna print. Pretty easy, right? So next, so you just have to define your own error handler. Fine. It would be better if it had default error handler, but it does not. Which I guess lets you do your own stuff. It doesn't force anything on you. But on the other hand, I would love if it had a default one and a better way of handling errors, I think. But this is also fine. I mean, not complaining or something like that, but kind of complaining, right? I really like Rust's way of handling errors, right? But it doesn't have that. Still, it's fine. Readers. Strings.new reader, hello reader. It just makes bytes. So B is of size 8. So it just treats 8 character of it. That is hello R. Then it treats the remaining 6 characters hello reader. And then it does not read anything. So this is how it works. Next. Okay, exercise, root reader go and just copy this and paste it right here. Simple, okay, with a 13 letter after it. Okay, so what I can do is just increase by 13. It seems I dot copy when statistic out is the reader. I have read P. P is the bytes. So if P is greater than A and less than Z, P is just added 13 basically. And this is for the small letters. And I'm doing the same thing around here as well. So this is how it works. And I think I passed the test. Images. So what is image? Package image defines image interface. Image.new RGBA is just image.rect is a rectangle. It's just the bounds of the image. It's just the RGBA value of it. Oh, cool. Next. So what I have to do is make two functions or methods, bounds and color model. So for that, I'll first define a method called bounds that should return the type of image.rectangle, and another method called a color model. So so this is the bounds. So this is color model, and this should work, right? I didn't. You just return RGBA model, nothing else. I was just overthinking it then. Still didn't work. Looks like this works. Color.color. It doesn't even say color.color. Why does it? Okay, at should return a color. Okay, dude. I just didn't read it. Okay, fine. Got it. I just didn't implement this. I'm such a noob. Okay, next. Congratulations, you have finished the lesson. So I think that is it for today's video. And I didn't do the exercise properly this time. Like the last time, I didn't get neuron absent. I don't know. I'm still under by that. Anyway, thank you for tuning till the end. So I'll see you in the next video. Bye.